The next generation air transportation system, that statement implies that the current air transportation system is being replaced. Why is it going to be replaced? When are these replacements going to happen? And what are the changes that are going to take place? This presentation is going to answer those questions and more. Hello, my name is Stephen Smothers. I'm a technical pilot here at NextGen Aviation. I work in aircraft systems engineering. A few years ago, our team was asked to become experts on the next generation air transportation system and the underlying technologies. Today, we're participating on technical work groups and committees and collaborating with the FAA and industry to hammer out some of the issues that will impact business aviation and general aviation. So from that activity, we've learned a great deal, and we're going to share that with you today in today's presentation as we look at what is NextGen. As an overview, we're going to look at what is NextGen, why NextGen is essential, how will NextGen be implemented. We'll take a look at the global regulatory requirements, and then Destination 2025 and beyond. What will the next generation air transportation system look like? So first, let's begin. The next generation air transportation system is a system of subsystems. There are support systems and there are operational systems. Today, we're going to focus on the operational systems and how they are changing. Modernized aircraft systems, along with modernized ground and satellite infrastructure, will enable more efficient and predictable operations in the future. Next, we're going to watch a video describing NextGen operations. This video was created by the FAA to educate the traveling public about NextGen. The technologies and concepts presented are exactly the same for business and general aviation. Let's watch.
As an airline passenger, you may barely notice the changes taking place over the next 10 years to improve your flight. But you will appreciate the increased safety, environmental benefits, and reduced delays as the next generation air transportation system is adopted. To best illustrate the benefits of NextGen, let's first look at how your flight, say from Los Angeles to Washington, is managed today. As your plane pulls away from the gate and gets in line, your pilot is talking to controllers in the LAX tower for critical routing information. After takeoff, a TRACON controller steers the pilot through maneuvers to rise thousands of feet while covering about 100 ground miles. At about 23,000 feet, your pilot talks to another controller at Los Angeles Center, who directs the plane to its final cruising altitude of 35,000 feet. Across the country, your plane follows other planes like cars on an interstate highway. As with cars, the route is dictated by what's on the ground. Your plane must pass over radar fixes, generally not the most direct path. And every time the plane crosses an airspace boundary, your pilot changes radio frequencies more than 25 times cross-country and makes adjustments in the flight, speeding up, slowing down, and changing direction. Bad weather over, say, the Midwest will force your plane into inefficient flight paths and keep other planes on the ground, creating delays that ripple throughout the country. When your plane begins the slow descent into Washington, your pilot steps down, levels off, and speeds up, while also moving around to safely align with other traffic on the way to the runway at Dulles. Now, let's look at how NextGen will improve your flight. Improvements kick in as your plane leaves the gate. Surface traffic management on the ground makes things simpler, safer, and more orderly for both pilots and tower controllers. For one, they spend less time talking to each other on the radio. This reduces communications errors as digital data communications, similar to text messaging, expedites clearances. The order of departure is set automatically, reducing long waits and enhancing safety. As the plane heads to the runway, pilots and controllers each have a real-time GPS map of all ground traffic with such tools as ADSB and ASDX. This greatly improves airfield safety through a reliable shared view of the plane's surroundings, particularly during bad weather. During takeoff, precision RNAV and RNP procedures allow multiple departure paths from each runway, which increases airport capacity. This same precision gets your plane quickly out of the busy lower-level airspace to cruising altitude while saving fuel. At 35,000 feet, GPS-enabled RNAV, RNP, and ADSB allow planes to fly closer together without any loss of safety, which increases airspace capacity. Meanwhile, aircraft fly more direct paths that account for wind, destination, traffic, and weather. Weather, which now accounts for 70% of delays, becomes less of a problem. That thunderstorm over the Midwest that causes so much trouble today will be easily handled when shared network-enabled weather information is fused into decision-making tools through SWIM. Data communications, so useful in the airport, is also useful in the air, as it reduces radio frequency congestion, errors, and delays. As your plane lines up for arrival with other planes, its place in line is planned hundreds of miles in advance. Instead of the current step-down approach, tailored arrivals and then continuous descent arrivals allow a smoother descent into the airport. The more precise landing paths allow steady descent with reduced power. This cuts time, fuel, noise, emissions, and holding patterns. As your plane comes in for landing at Dulles, Data Communications relays the runway exit point, assigned gate and taxi route to the pilot, so you quickly arrive at the gate doors, exit the plane, and pick up your luggage. As a NextGen passenger, you may notice a smoother flight, but what really gets your attention is being on time more often. You also know flying is safer and more fuel efficient, and that's what matters from gate to gate.
NextGen is the FAA's CNS ATM Modernization Initiative. The acronym CNS ATM means Communication, Navigation, Surveillance, and Air Traffic Service Management. It is the term used internationally for the global modernization of air traffic services. NextGen is a 20-year endeavor to update older systems with new technology. Older systems are reaching the end of their service life. Once complete, it will support a twofold increase in traffic in the upcoming decades. This modernization effort began over 12 years ago when President Bush signed the Vision 100 Century of Aviation Bill into law. NextGen will radically transform flight and air traffic control procedures from air traffic control to collaborative air traffic management. NextGen will equip controllers with automation tools for better decision-making. New tools will allow controllers to shift from solving tactical airspace management problems, which involves a high cognitive workload, to focusing on the strategic management of traffic streams. Together, these changes will result in an increase in airspace efficiency, capacity, and predictability, all the while reducing noise and emissions. The NextGen status. What is the status of NextGen today? In short, it's still under construction. In 1956, the National Interstate Highway System infrastructure was being developed. It took 35 years to lay over 47,000 miles of interstate. Yet, while that program was under construction, local areas and regions benefited from the new transportation infrastructure. NextGen is similar. Operational improvements are being realized today. And, as we go forward, Operators will want to be aware of new equipage options to ensure they can take advantage of the latest improvements to complete the mission most efficiently. Moreover, owner-operators will want to understand the NextGen roadmap to determine when will be the best time to equip their aircraft to realize maximum payback. Why is NextGen essential? Today, information and commerce are moving at the speed of light. We need an efficient and responsive air transportation system to keep pace. However, today's system is challenged. When weather events occur, the system quickly slows down, affecting operations nationwide. In addition, obsolete systems and procedures contribute to airspace inefficiencies. To help illustrate why upgrades to our national air transportation system are essential, we're going to listen to a conversation between a pilot and a controller that took place recently near Wichita. I call it the Jabara Dreamlifter incident. It clearly involved pilot error, but it allows us to pull back the curtain, if you will, and examine some of the outdated structures that are in today's air transportation system. A modified Boeing 747 was en route from Italy via New York to Spirit Aerospace Systems in Wichita, Kansas, to bring parts for the Boeing 787. Spirit Aerospace has access to the runways at McConnell Air Force Base. The pilots landed at Jabara Airport. Jabara is approximately 9 miles to the north of McConnell. Here you can see the runway orientation as seen from the pilot's perspective. Jabara is only 6,000 feet long, and McConnell is 12,000 feet long. Fully fueled and loaded, the Boeing 747 needs more than 6,000 feet to take off. After we listen to the exchange between the flight crews and the tower controllers, we will discuss the shortfalls in today's communication, navigation, and surveillance systems. Then, throughout this presentation, I'll point out where the new technologies may have helped prevent this event.
41 Heavy is on the GPS, RNAV GPS approach 19 left.
Skyline 4241 Heavy, McConnell Tower, check those down, runway 19 left, wind 140 at 4, clear to land.
Clear land, runway 19 left, wheels down, Giant 4241 Heavy.
Giant 4241 Heavy, check those down.
Giant 1441, go ahead.
Giant 4241 Heavy, check those down and expect midfield turn off, check for Delta.
Giant 4241, we might, we'll get back to you here momentarily, we're not on your approach.
Giant 4241 Heavy, McConnell is 9 miles southeast.
Yes, sir. We just landed at the other airport. And McConnell, Giant 4241.
Giant 4241 Heavy, McConnell Tower.
Apparently, we've landed at BEC.
Giant 4241 Heavy, verify you are on the ground at Beach Airport.
We think so.
Giant 4241 Heavy, McConnell supervisor, verify you are full stop, landed and stopped at BEC Airport.
Affirmative.
Giant 4241 Heavy, McConnell Tower, are you able to make an approach correction departure off that airport and back in the air to McConnell?
And we're working on those details now, sir.
Roger.
And McConnell Tower, Giant 4241.
Giant 4241 Heavy, McConnell Tower.
Yes, sir. Is there a tower frequency here for beach?
Giant 4241 Heavy, beach tower is actually closed at this time. It's on the end.
Okay, is there a Unicom frequency?
Giant 4241 Heavy, stand by.
And one more thing. Do you have the coordinates for this for the airport?
Giant 4241 Heavy, stand by on that.
Okay, thanks.
Giant 4241 Heavy, have the coordinates 530 southeast.
Ready to go. Go ahead.
Beach is Kilo Bravo Echo Charlie, north 37 degrees, 41.64, west 97 degrees, 12.90. Outside.
Okay, let me read those back. North 374164.
Affirmative.
Okay, and then east 92129.
West 97 degrees, 12.90.
Sorry about that. I couldn't read my handwriting. West 9212.90.
Transforming the airspace. Let's take a look at the shortfalls with today's air transportation system. First off, today's surveillance. McConnell Tower did not know where Giant 4241 Heavy was, as you heard. New surveillance technology will enable aircraft to be seen even when on the airport surface. Today's voice communications, well, you could see it took nearly 3 minutes for Giant 4241 Heavy to ask for help to find out where he was. New communication platforms will enable routine information to be transmitted discreetly and directly via text. Today's navigation system, as you saw, Giant 4241 Heavy left his navigation system behind and went for a visual approach. Obviously, this caused the mistake, but why? Why did the pilot have more confidence in sighting the airport than trusting the navigation technology at hand? New satellite-based navigation systems are becoming more accurate than ground-based systems. In the future, pilots and controllers will know for certain where the aircraft is, whether it's in flight or on the airport surface. So how will NextGen be implemented? The answer is, in some regions of the world, by equipage mandates. But in others, it's mainly going to happen through incentivizing voluntary equipage. How do you incentivize voluntary equipage? Well, let's just use the interstate highway system for an example. Around major cities, many interstate highways have an HOV lane to expedite throughput. If you're equipped with the right number of passengers, you can pass a lot of other commuters that are stuck in traffic. Yet, there's no mandate to carpool. NextGen calls this best equipped, best served. It's improved services for operators who make the investment. So the incentive is improved services. In other words, it's all about access. Access to airports and access to airspace. Another way it's going to be implemented is through the Global Performance Improvement Roadmap. It's also known as the System Block Upgrades. Looking at this chart, you can see it's divided into 5-year blocks. Each block describes the upgrade needed to support the overall effort in each time frame. The International Civil Aviation Organization is coordinating with nation-states to ensure future air traffic management technologies will be compatible and interoperable. For operators to realize the full benefits available in each block, it is important that the service providers like the FAA and the operators invest in the NextGen technologies. Next, we'll look more in depth at each operational system and the capabilities. These are the building blocks of NextGen. It's important to note that not all of these systems and capabilities will come online at the same time, so keep in mind, NextGen is still under construction. Let's take a look at the first system, air traffic surveillance. First, let's review how aircraft are identified and tracked today. Since World War II, radar technology has been the backbone of air traffic surveillance. Primary radars sweep the sky and simultaneously listen for a return or a ping from an aircraft's metal skin or engines to determine the distance and heading relative to the radar tower. Secondary surveillance radars interrogate the aircraft transponder to request information. Once prompted by the radar, the transponder replies with altitude and aircraft identification information. However, there are limitations with this system. First, the refresh process can take up to 8 seconds. Second, it has limited accuracy at long range. This leads to increased spacing requirements for en route flights and system-wide inefficiencies. Finally, radars are expensive to maintain. There's a lot of moving parts. Radar beacon technology limits the distance aircraft can fly next to each other. To increase airspace capacity, aircraft will need to fly closer together. To fly closer, pilots and air navigation service providers will need to know the exact location of all aircraft. The FAA and its global counterparts are replacing ground stations where feasible with a new satellite-based surveillance systems. The new air traffic surveillance system is ADSB. This acronym means Automatic Dependent Surveillance Broadcast. Surveillance broadcasts begin as soon as a pilot powers up the aircraft's onboard avionics system. ADSB is foundational to NextGen and the worldwide initiative to modernize the air transportation system. Let's take a look at how it works. First, an aircraft locates its position via the GPS satellite network. It then begins to broadcast automatically its position and identification information to other equipped stations. This is called ADSB out. Surveillance broadcasts are automatic. They are picked up by all compatible receivers that are in range, regardless of whether they are ground stations or on board other aircraft or on a surface vehicle. An aircraft equipped with ADSB in can see other ADSB out transmissions. A display in the cockpit enables pilots to see the same traffic situation as controllers, whether in the air or on the surface. If an aircraft is on another ADSB frequency, it can be seen through the ADSR or ADS rebroadcast system. Aircraft information is automatically transmitted as soon as the aircraft avionics are turned on. No pilot input is required. Position information is derived from GPS. Surveillance information is dependent upon the aircraft's ADSB transponder, and it broadcasts latitude, longitude, altitude, speed, aircraft intent, and much, much more. I call this smart data transmissions. In our example, if Giant 4241 Heavy would have had an ADSB transponder, the tower controller could have been able to locate his positions instantaneously. Likewise, they may have seen him descending too soon for the approach, and they may have been able to divert him earlier. By knowing exactly where an aircraft is at all times, there will be fewer errors like this. Let's look at the ADSB transponder varieties. There are two ADSB variety options available in the U.S. and China. For operations below flight level 180, a universal access transceiver is the best choice. It includes ADSB in and has some additional features like free graphical weather and traffic information. However, the global standard is a 1090 extended squitter transponder. It is required for operations above flight level 180 and by mandate in airspace outside of the United States. ADSB-in is not required as of yet in any airspace. However, there are several advanced features that ADSB-in provides that will be necessary for next-gen operations. So as a rule of thumb, if you have a transponder today, you will require ADSB out tomorrow. This graphic depicts the airspace where ADSB out will be required in the United States. Basically, if you want air traffic services, then you will be required to have an ADSB out transponder. I'm asked if there are any benefits to equipping with an ADSB out transponder before the mandate. The answer is yes. ADSB out is opening up new airspace that was once uncontrolled. Here's an example. It's a flight from Los Angeles to Miami. Today, an ADSB out equipped aircraft can receive improved separation services and go directly across the Gulf of Mexico. In this example, the trip is 300 miles less. That saves time and fuel. When ADSB in becomes available, it will unlock advanced applications allowing pilots to conduct what I called electronic self-separation. ADSB out directly benefits the air traffic controller, no doubt, but ADSB in will directly benefit the pilots. Here's a depiction of ADSB in symbology with traffic alerts. This is great for situational awareness, but it's just more than just a high-definition version of TCAS. These symbols represent exactly where the aircraft are in time and space. Next, we'll briefly look at flight interval management. Flight interval management is an emerging technology that will increase system throughput. Initially, it's going to be used in the en route airspace to sequence aircraft converging over an entry fix before descending into a high-density metroplex. ADSB out and ADSB in technology is foundational to flight interval management and enables the transition from air traffic control to collaborative air traffic management. Next, let's discuss the innovative changes in pilot-controller communications that are coming soon to next-gen airspace. Voice communications. To date, communications between the pilot and the air traffic controller have been entirely over the two-way radio. Voice communication is very inefficient because only one person can speak at a time, and it's very workload intensive. Each person has to listen very carefully so as not to misinterpret the message or speak when others are speaking. It is possible for the communication to also get interrupted or misunderstood by another pilot with a similar call sign. So what's the solution? Let's watch this next video from the FAA and see.
Roger from India, and we can expect that time. 106.
Listen, you can hear a quiet communications makeover as NextGen moves aviation from voice to text. Data communications is more efficient, flexible, and safe. And combined with other NextGen technologies, Datacom opens up great possibilities for the future.
It really is kind of a game changer. If you compare it to our daily lives, it was almost communication before texting or email. Telephone communication was a great way to do that, but if you had to get a message out to a bunch of folks, playing the telephone game 20 times over was very inefficient. And for us to be able to receive our clearances and coordination stuff through this email-like service is so much more efficient. It's clear, it's readable.
This becomes more important as traffic increases and we accommodate new users of the national airspace. Old two-way voice radio won't be able to keep up.
When you're trying to read a very lengthy flight plan and they read it back wrong, I have to go back and fix that. And that will take several fixes occasionally. So it is a challenge that Datacom will do away with.
Here's how Datacom speeds up the departure clearance process. Each flight crew receives route instructions from an air traffic controller prior to taxiing. The pilot of the voice-only communication plane in red listens to the transmission from the controller,
Papa X-ray Victor.
then repeats it to make sure he has transcribed everything correctly.
Okay, so that'll be the Newark 1 radar vectors, Newell, J6, Danner, Ravine, J64.
Sometimes this takes more than one exchange before everything is clear, and the process takes several minutes depending on how complex the route information is.
After Newell, it's J60.
J60 after Newell.
If there are reroutes to deliver, the process bogs down even more. With the Datacom-enabled plane in blue, the controller sends digital route information directly to the plane's Datacom receiver. The pilot simply reads the text display and presses Wilco for Will Comply. Then the instructions are loaded directly into the onboard computer system. This takes only seconds. When we look at this process across the operation, the time savings are significant. Those time savings mean a more efficient system. In this scenario, while just 2 voice-only planes have been cleared for takeoff, 5 Datacom planes are already on their way. As more Datacom planes are cleared for takeoff in mere seconds versus minutes, the time savings and departure volume continues to increase. This is the key benefit of Datacom in the departure clearance process. By increasing efficiency of operations nationwide, the result is fewer delays from the outset.
So this is just the tip of the iceberg, ground reroutes. Soon we'll have the ability to do things in flight, basic stuff such as altimetry changes, frequency changes, and eventually we'll move into more complex clearances while we're flying. But once we have the system in place, I think it'll really speed up the entire process of every transaction that we do with an air traffic control facility.
Datacom is built on the foundation of NextGen's primary infrastructure, including systems already in use, like ERAM and ADSB. These tools help provide relational information or situational awareness to both planes en route and to controllers. With Datacom, controllers will be able to transmit complex reroute information to several planes at once in a sector. The time savings will be significant.
When you start getting into more complex clearances and additional information that needs to go into those clearances, that's going to take time on a frequency. To have the ability to send that message with all those different elements to the flight deck without having to voice it and then get the readback and verify it because it's going to be verified right there in front of them and loaded into the system, it's going to benefit everybody.
It will also result in tremendous efficiency. Controllers can adjust routes earlier and more gradually, and see the impact of these changes on all planes in the area. The cost savings in terms of limiting delays, reducing fuel use, and streamlining traffic flow will be huge.
A few years down the road, everything's going to be going through Datacom to make it more efficient. Everybody that I talk to that says, man, we're going to be able to send revised clearances to the flight decks, they love it. They can't wait to get it.
Tests with FedEx in Memphis and United Airlines in Newark show cost benefits and reduced delays.
Newark is generally the most delayed airport in the country, and a lot of that has to do with the weather. And as I've gone through the project and learned more about it, and seeing it from the industry and the pilot side and the benefit to them, it even exceeded my expectations of the benefits.
NextGen is transforming flight routing procedures, increasing efficiency, flexibility, and safety. These changes to our airspace translate into time and money saved for airlines and a better experience for the traveling public.
Data link comparison. Some aircraft are equipped with an ACARS data link system today. You may know it as AFIS or Unilink. However, this is not the same as the datacom system to be used for air traffic control. The new system for air traffic services is called CPDLC, or Controller Pilot Data Link Communications. Today, there are two dissimilar CPDLC technologies in use. One's called FANS 1A and the other is called Link 2000. They're like different computer operating systems. They have their own language and are not interoperable. A future CPDLC operating system is being developed called ATMP2, or Aeronautical Telecommunications Network Baseline 2. This will be the global data communication language, like English is, as the universal aviation language for voice communications. By 2023, ATMP2 is expected to be the standard for the global data communication language. So, how does it work? First, air traffic control sends a pre-formatted text message to the cockpit. This starts a timer to ensure that the message is received and acknowledged by the pilot. When the CPDLC unit receives the message in the cockpit, the pilot is notified by a light and an oral alert. Once the pilot reads the message, he or she can either accept or reject the message with the push of a button. If the pilot rejects the message, the pilot and controller will either exchange more text messages or communicate by voice. If the pilot wants more time to decipher the message, he or she can push standby. This pauses the timer for a period of time. If the message involved a reroute and the pilot accepts the new routing, he or she can command the new route directly into the flight management computer. This eliminates errors of omission and wrong key entry strokes. Remember Giant 4241 Heavy? If he would have had CPDLC, McConnell Tower could have texted him the Jabbar coordinates directly. This would have saved time and errors. The final NextGen system we'll discuss is the navigation system. Satellite-based navigation is by far the most mature building block leading to full NextGen implementation. To help with our understanding of satellite-based navigation, I'm going to define some terms and discuss the operational capabilities that they unlock for the user. RNAV, or area navigation, is navigation from one waypoint to the next. Waypoints are points in space defined by precise latitude and longitude. RNAV increases airspace efficiency over conventional ground-based navigation. To further increase airspace efficiency, air navigation service providers like the FAA require an aircraft to meet minimum navigation performance standards. This is known as RNP, or Required Navigation Performance. The required navigation performance is specified in miles, from 10 to 0.1. The smaller the number, the smaller the containment zone, or the boundary that the aircraft must stay within. If the aircraft exceeds the boundary, then the pilot is alerted. It's kind of like rumble strips on the edge of a highway. This is the alerting and the monitoring feature an aircraft must have to meet RNP requirements. RNP can provide a seamless vertical path and a curved path for en route airways and departure and arrival route construction. This technology will optimize airspace usage. Some of the benefits of NextGen are available today. For example, with Wide Area Augmentation Systems, or WAAS, they're also known as SBAS, they provide a correction factor to the GPS satellite-based approaches by correcting the GPS signal. This allows pilots to continue an approach to lower minimums and get under the weather to see the runway for landing. LPV is an acronym that stands for Localizer Precision with Vertical Guidance. Satellite-based navigation can align the aircraft with the runway centerline and provide a vertical glide path for landing. If you reference this graphic, you can see that WAS LPV allows pilots to continue to a 200-foot decision altitude, or DA. Most airports that previously had Instrument Landing Systems, or ILS, now offer an LPV approach, and LPV approaches are becoming available at airports that previously did not have an ILS. However, LPV technology alone cannot replace the costly ILS systems that allow pilots to fly even lower minimums to try to get under the weather and see the runway or to land. However, ground-based augmentation systems, or GBAS systems, will. GBAS landing systems, also known as GLS, have the precision of an ILS, but with more capability at less cost. A local station can provide correction signals for precise navigation that is accurate to within 3 feet. A single GBAS station can cover all the approaches and taxi operations at the airport. GBAS enables curved approaches with vertical guidance all the way down to touchdown. GBAS can even provide displaced thresholds and low visibility taxi routes. But this is just the beginning of satellite-based navigation. Time-based navigation is what is to come next, and it is a game changer. This is where all the next-gen technologies are in full use to enable a new capability that's known as four-dimensional trajectory-based operations, or 4D TBO for short. Pilots will be assigned a time to cross a waypoint to ensure proper sequencing of aircraft. The assignment is called an RTA, or Required Time of Arrival. Complying with an RTA is similar to complying with a vertical crossing restriction at a waypoint. The automation tools I mentioned earlier will help controllers sequence and space aircraft in 4 dimensions. Aircraft with a capable flight management system and autothrottles will be able to comply with this clearance. This will allow pilots to optimize his or her flight path from takeoff to landing. The final comparison to Giant 4241 Heavy is this. If they had been assigned an RTA to land, then they may have noticed that they were about to land 3 minutes too soon. Now, this next video will show how time-based navigation works. It will also show that next-gen technologies are global because this video was produced not by the FAA but by the European counterparts. Let's watch I4D.
The first I4D trajectory flight trial took place in February 2012. It was a world premiere. 4D means 3 spatial dimensions plus time. Time represents a key element in the transition from constrained flights in the current ATM system to optimized flights. I4D operations establish far ahead of time a sequence for aircraft converging on a merging point, which is particularly crucial in congested areas. After coordination between the ground systems and the aircraft, each aircraft is allocated a time slot for its arrival at a merging point, and in compensation is allowed to fly to that point without any vectoring instruction from the controllers. Current validation exercises and flight trials have demonstrated several reductions, in average time spent in holding up to -100%, in distance flown per flight -6%, in number of potential conflicts by -68%, and in average fuel consumption per flight -11%. In the future, thanks to I4D trajectory, ATM operations will be automated to a greater extent than they are today, and the European sky will be able to cater for more efficient flights than it can today.
Okay, switching gears now to the global regulatory requirements. Let's focus on the mandates. In the U.S., there's only one mandate for NextGen. To receive air traffic services after January 1st, 2020, all aircraft are required to be equipped with an ADSB out transponder. This is the only NextGen mandate for the U.S. The FAA believes that the operational benefits of other NextGen technologies like Datacom, RMP, and 4D TBO are so compelling, operators will want to equip their aircraft to take full advantage and have optimum access to airspace and airports. A look at this map reveals ADSB out mandates in other regions. First, in the Australian and Asia-Pacific region, an ADSB out mandate has been in effect for operations above flight level 290 since January of 2013. Beginning in June of 2016, it will be required in Europe for new aircraft weighing more than 12,500 pounds or capable of airspeeds greater than 250 knots true. And we've already discussed the USA mandate. The Datacom mandates. The European Datacom mandate was moved to February 5, 2020 for all operations above flight level 285. As of today, the CPDLC technology for this mandate is Link 2000. It's also known as ATN-B1. However, it's still possible that the European Union could decide to leap to the next system block upgrade for Datacom and require ATN-B2 instead. We're monitoring the European requirements closely. To operate above flight level 290 over the North Atlantic region, all aircraft are required to be equipped with FANS 1A by January 30, 2020. This will include the entire North Atlantic, not just the organized track system. However, aircraft without FANS 1A can still navigate in this region by using the northern routes over Greenland and Iceland. Once ATN-B2 is available, an operator equipped with either FANS or ATN-B1 will retain CPDLC capability because ATN-B2 will be backwards compatible with these Datacom systems. Although not a mandate, the FAA is confident that the operational benefits gained from Datacom will incentivize operators to equip with CPDLC based upon FANS 1A+. Beginning this year in 2015, the FAA is installing CPDLC for departure clearances and revised departure clearances at selected airports. By the end of next year, this capability will be at 56 of the busiest airports in the nation. The airports are listed on this chart. Beginning in 2019, the FAA will begin giving routine instructions using CPDLC in the en route airspace. The FAA chose FANS 1A+ because it is a proven and mature technology. The advantages of FANS are many, but the primary advantage is that the new capability can be integrated with the navigation and the communications system. As we saw, this is a key building block of NextGen. Because a mandate for navigation equipment has not been necessary thus far, there's not a mandate. Navigation has always been driven by utility and access. These are a function of pilot training and aircraft equipage. To fly in low visibility conditions, pilots and aircraft must have the necessary authorization, training, and approvals. As aircraft equipped with NextGen technologies, air traffic controllers will be able to identify the aircraft's navigation, surveillance, and data communications capabilities using smart data provided by ADSB. When the visibility is low and high-density airspace, controllers will be able to give the aircraft that are most capable the best access to airports and airspace. This will keep the airspace fluid and will increase overall system-wide throughput. Aircraft that are less capable will be given access, when the airspace is less congested. This is best equipped, best served policy in effect. Destination 2025 and beyond. Once the ground infrastructure is in place and aircraft flight decks are modernized and pilots and controllers are trained, the transformation to the next generation air transportation system can begin. System transformation. The air transportation system was developed in the 20th century. Until radar was deployed, air traffic control could only keep track of aircraft using pilot position reports. Basically, they had to estimate where the aircraft was. However, today, we have published airways and departures and arrival routes. By using the radar beacon system, air traffic control can know where the aircraft is in most airspace. However, in the 21st century, dynamic routes will be used instead of published routes for the management of air traffic. Air traffic control will not only be able to precisely locate and track aircraft from the surface and up, but they will be able to know where the aircraft will be in time and space. This is NextGen airspace. Beyond 2025, it will be a new frontier. There will be virtual highways in the skies. To do so, NextGen aircraft will be fully integrated with systems on the ground. Real-time surveillance will enable pilots and controllers to know the precise location of all participating aircraft, whether they're manned or unmanned, or whether they're on the surface or in flight. This will allow a safe reduction in separation criteria and increased airspace and airport capacity. High-speed digital communications integrated with four-dimensional navigation, will enable next-gen equipped aircraft to be sequenced from other next-gen equipped aircraft in time and space. This will increase airspace efficiency, optimize airspace usage, and reduce holding and minimize delays. Performance-based navigation will enable precise ground tracks from taxi to takeoff and during climb, cruise, descent, and landing operations. This will increase airspace and airport throughput even under low visibility operations. The next generation air transportation system will be fully integrated, responsive, synchronized, and globally harmonized. However, there may still be aircraft without the advanced technologies in 2025. These aircraft will have limited access and will not be able to fully participate in this modern airspace until they are next-gen equipped. In summary, we've talked about what is NextGen. It's the FAA's initiative to modernize the airspace. NextGen is still under construction, but operational benefits are being realized every day, and there will be more operational benefits in the years to come. We've also discussed why NextGen is essential. A safe and efficient air transportation system is vital to the nation's economy as well as the global economy. And we discussed how NextGen will be implemented. It will take stakeholder participation. Air navigation service providers, industry, and owner-operators must work together to unlock the full potential of the new system. That's NextGen 101. Well, to summarize, we've talked about what is NextGen. It's the FAA's initiative to modernize today's air transportation system. Although it's still under construction, we're starting to realize some of the operational benefits today, and there's going to be a continuous rollout of operational benefits in the years ahead. We've also talked about why NextGen is essential. A safe and efficient air transportation system is vital to our nation's economy as well as the global economy. And third, we've discussed how NextGen is going to be implemented. It's going to take stakeholder participation, including the air navigation service providers like the FAA and industry, manufacturers, avionics, and airframe manufacturers, along with owner-operators, fully working together to unlock the full potential of this next-gen airspace. I think it's an exciting time for aviation. There's lots of work to do in the years ahead. These technologies that we've talked about are transformational. It's going to transform flight operations and flight deck design. It's going to be a new paradigm for aviation in the years up ahead. And I'm looking forward, personally, to flying the first fully equipped next-gen business jet, as long as it is in a new citation. Well, thanks for watching. I hope you have a great day.